questions. Hello class, welcome to the 30 questions per day applied logistic questions analysis. And this is basically our third questions under the analysis. The question states that we should find the total resistance in the circuit in figure 2. That's basically the figure 2. Okay. So labeled. So the total resistance, we can redraw the circuit and we know that basically that this is a series path. Why is it a series path? Because when the current is moving, it will just move without branching to another circuit. Okay, so we can say this and this are in series. So we'll draw the circuit nicely and add the two together. That will give us 3 ohms. Okay, and then we have another resistance in parallel to it, which is the 3 ohm resistance, and we have a resistance in series with the source voltage, which is 4 ohms. And then finally we have the source, which is the senior man, 5 volt. Okay, now to find the total resistance, what you have to look at is to always start with where there is no source, right? So we can solve this and this in parallel. Why are they in parallel? They are in parallel because there are two terminals are directly connected together, so we can solve it together, right? So we can say we have 3 power 3, and that is the same as 3 times 3, all on 3 plus 1, 3, and that will give us 1.5 ohms. Okay. Or another way to solve it is that anytime you want to find the resistance of the total or equivalent resistance at a certain point, and then the resistances are all in parallel such that they have the same value. So we have 3 ohms here, 3 ohms. So you just take one of them and divide by n, the number of resistances. So that will give us 3 divided by 2. And that will equally give us 1.5 ohms. Okay. So now our circuit will now tends to be this one. So we have 1.5, the one we resolved, and then the 4 ohms, and then finally we have the source, which is 5 volts, right? So to find the total resistance, you just add the two together since they are in series. So the total resistance will be 4 plus 1.5, and that will give us 5.5 ohms in a circuit. Okay. Now that was actually the first question. So we have 5.5 here. Okay, we have 5.5 here. Okay. Now the next question says that we should find the voltage drop on the 3 ohms resistance. So the voltage drop in the 3 ohms, which is the voltage drop at this point, right? So how do we go by that? We know that anytime we want to find the voltage, if we have current and you multiply by the voltage, that will give you the voltage at that point, right? So we first of all move fast track to go and find the total current in the circuit. So the total current in the circuit is the same as the total voltage divided by the total resistance, right? So the total voltage is 5 and total resistance is 5.5, and that will give us a resulting value of 0.909 amps in the circuit, right? When this 0.909 comes here, it's going to share between this and that. Okay, so let's just find the voltage division to get the one here. So we can say that the voltage division of the current division of the 3 ohms is the same as the opposite resistance, right? Divided by the summation of the 2, which is 6, times the total current, which is 0.909, which will give us 0.45 amps. Or another way to do this is to say that these resistances will share between this and this, but they all have the same resistances. So you can see that the resistance coming to the 3 ohms is the same as you taking just the total current 0.909 and dividing by 2. That will also give us 0.5 amps, right? So that's basically how to solve for that. So the value we had was so the question is for us to find the voltage drop in the 3 ohms, right? So we have the current there, so we can equally multiply by this. So the voltage drop in the 3 ohms will be equal to the current there, which is the resistance there, which is 3, times the current there, which is 0.45. That will give us a total value of 1.365, and that's what we have here. Okay, so that's what we have here. Now the next question states, which is question number 11, says that find the voltage drop on the 1 ohm resistance in figure 2. The voltage drop in the 1 ohm, right? Don't forget that the voltage drop here, when you have the current going there, you multiply by the resistance, you get the voltage. So So the voltage drop in the 1 ohm is equal to what? The current there, right, times what? The resistance. Now the current there is what? 0.145, right? Times the resistance, which is 1. So that will give us 0.45 watt volt. The voltage drop there is what? 0.45 watt. Okay. Now let's move on to the last question. Determine the total current in the circuit, right? We've already found that we said that it's the same as the total voltage divided by total resistance, which gives us what? 0.909. So we just go by that. So thank you very much, and then we are going to meet in the next question, which is question number 4. Bye. Then stay active, practice more, and you'll be able to do any question that will come on your way.